Hello everyone. My name is Tumwebaze Pius. So I'm going to do a presentation on explainable artificial intelligence and deep transfer learning for skin diagnosis. These are the authors, and the presentation is being presented by me, Tumwebaze Pius, and I'm affiliated to Makerere University, which is in Uganda. So this is going to be the content of the presentation. So, introduction. The first thing I'm going to do is basically define diagnosis. So, which refers to any form of treatment a given individual could receive from medical personnel or artificial intelligence-based system. So, diagnosis is very integral to the project because it's what we are trying to improve. So, we are using explainable AI along with deep transfer learning in the particular area of image analysis to aid and improve the diagnosis of skin diseases. So our problem statement, so skin diseases cause a huge burden globally in the area of health and as one of the most widespread human diseases in the world, according to a study. So skin illnesses are ranked as the fourth leading cause of human non-fatal burden. Accurate skin disease diagnosis is a time-consuming task for experts in the field of dermatology. So literally by design, based on the methods that were created, dermatologists carry out time-consuming tasks, which sometimes don't lead to accurate results. So this is our problem tree, shows all the problems related to skin misdiagnosis. So you have anxiety in patients, transmission of contagious skin diseases to others in case of skin contact. When a person doesn't know what disease he has, confusion in patients, uh, prolonged patient affliction, negative impact on a patient's mental health, prescription of medicine, and then you have time-consuming extensive tests which might not be accurate, nature of the tests, lack of access to high-tech medical equipment, infection under investigation, improper testing, and lack of time with patients. So research scope. So our study aims to focus on 10 skin diseases, that is melanoma, eczema, rosacea, psoriasis, contact dermatitis, acne, vasculitis, urticaria, erythema multiforme, and seborrheic keratosis. So the techniques we'll be using are explainable AI techniques like GradCam, LRP, and GraphLine, along with deep transfer learning and convolutional neural networks. So for literature review, skin conditions affect, or skin disease affect 1.9 billion people because of inadequate of some dermatologists. Many cases are seen instead by physicians with lower diagnostic accuracy because most dermatologists are very busy. So according to reports published by the National Center for Biotechnology Information, the low cost of productivity and treatment for people with skin cancer exceeded $1.2 billion, and over 5.1 million people experience serious side effects such as hair loss, infections, itchiness, and burns. So a conclusion was made that early detection of cancer could have reduced all of these cases. As a result of the fact that skin diseases are frequently regarded as minor contributors to worldwide illnesses, they are prioritized less than other high mortality rate diseases like AIDS, Ebola, tuberculosis, pneumonia, among others. So research questions. So how can deep transfer learning be used to improve predictive accuracy in diagnosis of skin disorders? How can explainable artificial intelligence be applied to the field of dermatology to increase adoption of artificial intelligence methods in general? Also, how can deep learning be used to automate diagnosis of skin diseases using imagery data? And to what degree can explainable artificial intelligence justify deployment of a skin diagnosis model for public use by dermatologists? All these are questions we aim to answer with this study. So these are objectives for our research. So to pre-process and prepare the dermatology dataset for model training, as well as make the pre-processed dataset available for further research and researchers in the community. To test and evaluate the deep transfer learning model, hence precisely determine how good the model is at diagnosing various skin disorders from a sample space of 10 classes. To deploy interpretability and explainability using explainable AI techniques like layer-wise relevance propagation and gradient weight class activation mapping for understandability of the learned skin disease imagery features. To justify model predictions using explainable methods and deploy the model in a mobile application that can be used by health personnel. To scrap the web and not only stop at detecting but providing the patient with viable content that can help them go about to treat the disease. So methodology. So deep learning has improved and experienced exponential evolution in recent years, while playing a tremendous role in image classification in various research domains. So research has shown that convolutional neural networks have achieved a high performance in detecting a lot of skin diseases, a lot of diseases like coronary artery disease, malaria, among others. So we're going to be applying deep learning, deep transfer learning, and convolutional neural networks. So the methods we use are convolutional neural networks, explainable AI, transfer learning, and VGG16. So we are going to implement a feature extractor on top of the VG16 ensemble of layers to train the model on how to detect skin diseases using features specific to our research problem. So research contribution. So currently, the traditional methods of skin diagnosis have these limitations. The results come out slow, that sometimes the tests are inaccurate, and because of the inaccurate tests, wrong prescription is given to patients. And also question the expertise of the health personnel. So our model using explainable AI and transfer learning will be able to give accurate diagnosis in record time to reduce all the current limitations of the current methods of skin diagnosis. So what are the expected results? So we expect a fully trained deep learning model that is capable of diagnosing 10 skin diseases in record time. It should also be able to differentiate the 10 skin diseases. Future works. In the future, we would like to implement more explainability techniques in Python, as well as to expand the number of diseases to be diagnosed. Yeah, so that's it for the presentation. Thank you.